Hello friends, this is Durga again from ITversity, and as part of getting started with HBase for Java developers, in this video I will try to cover data modeling briefly. I will not get into too many details, but I will try to load New York Stock Exchange data which is available on my GitHub account. There is a repository called data in this, and you can click on NYSE, and there is a tar file which is zipped. You can download this and untar it and unzip it, and you will have a bunch of directories and files which will look like this. So I am getting into the directory. And it will look like this. There will be multiple directories, and each directory have many files. I will try to open one of the file. And you can see the data in these files. The first column is stock ticker, and the second column is date, and then 4 prices: open price, low price, high price, close price, and volume. So we also have briefly looked at the HBase table earlier. We have created a table called demo, and you can scan the table and you can actually see the results. So there are 2 rows in this, and if you look at this, each row have a couple of columns with the column name as column 1 and column 2, and values as value 1 and value 2. So irrespective of the order you insert the data, first data will be sorted by the row key. So if you look at this, you see row key 1 first and then row key 2 second. So it will be in proper order irrespective of the way you store the data. Whether you first insert 2 or 1, the final result will be like this. And within each row key, if you look at this row key, there are 2 columns, and each column or cell have the name to it associated with it, and then the value associated with it. Okay, and if you look at this, even the column names are ordered. So again, irrespective of the order in which these column names are inserted, they will be ordered. So this is very important thing you need to understand, so that you can actually model your data to store in HBase table. So first thing here, yeah, they have explained earlier, HBase only offers 2 primitive operations to read the data. One is get and one is scan. Scan is to scan all the columns, all the rows with all the columns, unless you limit certain things. So scan by default will try to return all the rows in the tables, but you can do the partial scans. And also within the rows, as the column names are sorted, you can do the range scan on the column names also. So those are called as filters, and you can get different types of filters. Let me see the command. It is called as show filters, and you can see that there are many types of filters. I will not be covering any of these here. Probably in the a few days later, when I actually come up with complete content of HBase, I will try to touch all these filters in detail. But you can go ahead and explore these filters if you want in the meantime, and these filters will facilitate in filtering data using range operation on row keys as well as column keys. When you apply range operation on row key, you have to do scan operation, and then you can give start row and end row, and then scan will only scan the rows within that range, and it is called as partial scan. And again, within the columns also, the data will be sorted by column name. You can actually apply that range criteria using filters even on the column names. So, and one more thing you need to keep in mind is that you can actually do composite keys also, composite row keys. So when you actually define composite row keys, you can have multiple columns separated by a delimiter. And also another thing which you need to understand is each column name can have business value associated with it. Here there is no business value, we are just hard coding like column 1, column 2, but if you require, you can actually have business values as part of the column names itself. This is one of the major difference between traditional RDBMS and HBase, as I covered earlier. In here, traditional RDBMS tables, the column names are predetermined. You cannot change on the fly unless you perform DDL operation, and it's not typical to change column names on the fly. Whereas in HBase, each row can have different number of columns and with different names. So it's completely flexible. You can add columns on the fly, and those column names can also have business value. I will explain a use case here. So let's take the example of LinkedIn. I am logging into LinkedIn. And if you look at my profile, I have bunch of endorsements to my profile. You can see that there is a skill name here: Oracle, data warehousing, ETL, PL, SQL, data modeling. All these are nothing but skill names. And then I have the number of endorsements I have. So if I want to model it in traditional RDBMS, you will have a table which will have a unique ID, which could be your account ID, and then there will be a column called skill, and another column called endorsee, who endorsed you, and then for each and every endorsement, for each and every skill, there will be a new record in the table, and the index could be on the on all the 3 columns if you want to enforce uniqueness, which is the account ID, the skill name, and the endorsee. And then you have to perform means if you want to query the data, you have to give my name, and it will do the scan from using my name, and it will return the results. Okay. When it comes to HBase, if you want to model the same thing here, the way it will work is you will have the account ID as your row key, and within that your column name will be the skill itself, and your value for that column, which is skill, can be a comma separated endorsees if you want to store endorsees in that. Okay, that's how you can actually have your data model in HBase. So the advantage is, for example, in this case, I have Oracle endorsed more than 100 times, probably 120 or 130 times. And if you think about the traditional RDBMS, there will be 120 or 130 records with my account ID, with my skill, which is Oracle. All these things will be repeated 130 times, and then I will get the list of endorses. So there is a lot of redundancy in the data. Okay. To avoid that, you can have 2 different tables. One table will have endorsee names, and then you can have the foreign key, and if you model that way, you have to join these tables to render this page, and it can take forever. Using traditional RDBMS, there will be a lot of redundancy and the table structure can be significantly huge because you have to use the normalized data model, and the results will be repeated even though you can enforce unique constraint on account ID, endorsement or a skill set, and then endorse. When it comes to HBase, your account ID will be only one, which will be row key, and your skill set, for each skill there will be only one column name, and then you can have the endorses as the value which can be comma separated. And another way is you can actually have the skill set concatenated with the endorse name as the key name itself, and then you can have some random value like 1 or something, so that you can actually access the data a little bit faster. So it's up to you how you want to model it. But the major difference is your row key, which is your account ID, will not repeat as many times you got the endorsements. You will have only one record for all your endorsements, and LinkedIn supports 50 endorsements. So for that row key, which is the account ID, you will have 50 columns, and each column will have can have endorsement as the column name, and the values can be the comma separated endorses. So your data will be so concise, it can apply compression, and you can just pass the account ID and get the data into the application layer, and you can render this page pretty quickly. And also HBase supports scalability and all those things. That's a different story. As long as you understand the main difference between traditional RDBMS and data modeling using HBase, that is more than enough. Here, row key plays the very important role. You have to design your row key depending upon whether you want to do a partial scan or a full scan to get your result set. Now, going back to our New York Stock Exchange data, we have stock ticker, we have date, and then we have 4 different prices and volume. So if you want to do some application like moving average based upon volume, you just need volume, you don't need other fields. So what you can do is within HBase, you can have a column family for volume itself. So that column family will have only volumes. Other than that, it will not have anything else. And then your column name can be date, and your row key will be the stock ticker, and your column name can be the date suffixed with volume, and you can have volume for that corresponding date. So all your volumes will be together in one column family, and when you try to generate some reports or process data to get to do some analysis on volume, performance will be much better. So either you can have the stock ticker itself as the key, and have column names suffixed with the date, and have all these 4 prices and volume in one column family or different column families. It depends upon your requirement, and you have to understand your requirement and think the best suitable design, and you have to go with it. In my case, I just want to pass the date, the stock ticker and the date on which it is traded, and I want to see all the attributes for that combination. So what I want to do is I will do a composite key on these two, and then I can have 5 columns in the table. The column name can be like open price, low price, high price, close price, and volume. Okay. So for that, I already developed a simple Java application for to store the data into HBase, reading from these files, and I will show that in a moment. For now, let me disable the table. What is that? Table NYSE colon stock underscore EOD. list disable NYSE column stock data. Okay, that is the table name I am going to use. Truncate NYSE stock data. Okay, I just have to enable to truncate. And the now table is truncated. You can scan this, and there is no rows here. And you can describe this table, which will give the column family name. Column family name is SD, which represents stock data, and this is the table name NYSE column stock data. NYSE is the namespace, so you can use create underscore namespace and NYSE in single quotes. It will create NYSE namespace, and then create in single quotes. If you give NYSE column stock data, it will create this table in the namespace NYSE. That being said, let me review the code. So we need to read the data. So for that, I have created a simple plain old Java object called NYSE parcel. It has 7 columns: stock ticker, transaction date, open price, high price, low price, close price, and volume. And then for each record, I would like to invoke this pass function, which will pass the data by splitting with delimiter comma and assign those seven attributes for this class. So this is the main program, NYSE load.java. Let's go into the main function. This code will be synced in GitHub account, and you can download it and run it on your system with probably trivial changes. So first we are creating a configuration. We already created the configuration object using this format. It's a static variable, a static class level variable, and we are using HBase configuration.create to create the configuration object, and then we are setting up the quorum and port number, and I am using argument, so you can actually pass your zookeeper IP address or IP addresses if you are running HBase on a large cluster, and if you have zookeeper on 3 nodes in a cluster, then you have to pass the first parameter comma separated with all the host names that are running zookeeper. And then I have our hard-coded port number. Then I am creating the connection using connection factory, and then using connection object I am getting the table by passing the table name, which is NYSE column stock data, into this table instance, and then I am invoking a method called read files and load, and at the end we have to close table and connection, so I am closing the table and connection here. So now we will get into this read files and load. Read files and load is another method in this, and forget about this int counter equal to 1. It is not working as expected. So here there is another difference. Instead of using individual put command for each and every row, I would like to create array of multiple records and insert in one shot. For that I am creating the list of type put object, and then if you look at my data, I have so this will be the path for my input data, and from here I have to look into each of these directories, and each of directory have those files, and I have to read one file at a time and insert it, and I am trying to insert into the table for all the records from each of the files at a time. So this is a simple plain Java code which can read the file system. So I am actually checking whether the directories exist, and if it is a directory, I am looking into the directory and get the files with extension CSV, and then I am using buffer reader and reading each line at a time, and then I am passing the passing the data, and then I am actually once I pass the data, I am invoking another function called build put list, which we'll see in a moment. It takes two parameters, table and the parser object, and after we build the list for each and every file, I am actually invoking this load put list, and then I will be loading the data into the table. This should be outside. Yeah, this should be outside. Okay, so once I read the file completely and build this put object, then I would like to associate with load put list. Sorry, I would like to invoke this function load put list, which will actually put the entire list in one shot into the table. Here also I need some correction. Here is the, I don't need to create this array, and I would like to return put here. Okay, I don't need to have this actually. Okay, now here it should puts dot. Okay, so we are actually reading each line at a time and then building this list of puts, and once the entire file is read, then I'm passing these puts to this method called load put list, and that load put list will insert all the records in a given file. It might vary for each and every day depending upon number of records that are traded for a given day. So now the program is ready. Run as, run configurations, and here you have to pass the argument. The first argument is the zookeeper quorum, and the second argument is the parent directory for our raw data, and then click on run. It will take a while to run this. We can validate while it is running by running count NYSE stock data. It will take a while to create that connection and start loading. Once the connection is established, it will be little bit means it will be very fast to load the data. So now it started inserting the data. It is pretty fast. Let me see how many records I have in the table. Cat so it has 3.5 million approximately, so it will take a while to insert those many records. Okay, so anyway, we will look into it. If you want to just list few of the records using scan command, you can do this NYSE stock data, and you can open curl bracket and say limit and you can limit as many records as you want and hit enter. So now you can see that it returned 5 rows, and you can see that this is one row, this is second row, and then this is third row, this is fourth row, and this is fifth row. And then you can see that the column names are sorted, even though the actual data have open price first, and then low price first, and then open price, and then high price and closing price. Here based upon the column name, the data is sorted. First we got CP, then HP, then LP, then OP, then volume, because it is the sorting order. And then all these are floats, and internally it will be written as byte array, and by default it will show the values like bytes only, unless it is string. If it is string, it would have shown properly, but here there is no strings here. That's why it is showing with some special characters like this. I think there is a way to actually convert this into readable data also. I don't want to get into that at this time. So if you want, you can actually have one row key for your stock and move this date into the column names. So then the row key will be only A here, and then you can have column names either prefixed with this date or suffixed with this date. If you suffix with the date, then all closing prices will be at one place. All for the stock for the year for all the 6 years, all the closing prices will be together. Then all the high prices, then all the low prices, then all the open prices, and then all the volumes. So you can apply the filters on the row key. If you just want to get volume for a given range of dates, you can apply that filter and get the data pretty fast. So it is very important to keep this in mind, that your column names will be sorted, and if you think through the problem which requires sorting while reading the data, and if you embed and if you leverage these columns, implementing some business logic in them, and read the data in sorted order, if you store pre-sorted in the table, then your reads will be far more effective than traditional RDBMS. That is the actual power of the NoSQL databases like HBase. If you want, you can have just year in this, and for a given year for the row key, you can have all the dates, means all these close price, high price, low price, open price, and volume for all the dates for a given year associated with one row key. So it's it is called as lean and wide column family. In this case, we are using the linear approach. For each row key, we are only having 5 columns. But if you just have the row key with stock ticker and put all the data for that row key into that for the stock ticker into one row key, then you will have thousands of fields in that, and it will make your column family broader or thicker. So it's up to you how you want to develop your table. But you need to understand these fundamental aspects of data modeling so that you can come up with a good data model for your data. So to consolidate, you can either have just stock ticker as row key, or the combination of stock ticker and year as row key with the column names either prefixed or suffixed with the date, or you can actually have the stock ticker and year and month, and have all the records for that combination of stock ticker and year and month within that row key, or you can have it like this. And if you want to get individual record, you can use get function, and our table name is NYSE colon stock data, and the row key, let's say A comma 2009 0101, and hit enter. You can see that all the 5 columns are returned, and you can actually apply filters to get only range of column names from this data set. That is the power of NoSQL databases like HBase. Data will be sorted by row keys, and then within each row key, data will be sorted by column names, and that column names can be different from one row to another row, and also the data will be sorted by column names, and you can have business values inserted as part of your column names, which can be leveraged while filtering the data. That being said, I will wrap up here about data modeling. I will try to get into more details in the main course, but for now that is it. And I hope you are enjoying the content of my channel. If you like this video, please click on the like button. If you want to ask any technical questions or provide feedback about this video, please leverage the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will see a lot more content going forward. It will only get bigger and better over time. Thank you. Bye.